Hey, welcome back. So this week, DeepSeek released a brand new model called the DeepSeek R1 models, which is our first open source inference time compute models. It is meant to be competitive with O1, and if one more person tells me that this thing beats O1, I am going to lose it because the model is great, but it's not that good, and I'm going to show you why. So the good news is DeepSeek is planning to open source the model, although they haven't released the weights for it just yet. But you can check it out on chat.deepseek.com. And there's a bit of a limit at the moment. It's limited to about 50 messages per day, but it is enough for you to be able to play and understand that model. So what we're going to do is we're going to go to chat.deepseek.com, and then we're going to try out a few tests. We're going to look at math, we're going to look at reasoning, and we're going to look at a little bit at coding. And we're going to see how it compares against the O1 preview models. As you can see, it's fairly intuitive to get started with chat.deepseek.com because the UI looks like every single other UI for a large language model on the planet. The only thing you probably need to be aware of is if you want it to go into this deep thinking mode, i.e. use the inference time compute, you need to click on this deep think toggle there. So to get started with the deep thinking R1 model, one of the things I want it to be able to do is generate a valid sudoku grid. So I'm going to say using ASCII art, fill in a 9x9 sudoku grid so that each column, each row, and each of the 9 3x3 boxes contain the digits from 1 to 9. First number is 7, next number next to 7 is going to be a 3. So it's going to be 7 3, and then it's going to fill in the rest of it. And then if we click on that, it's going to start doing its magic here. So this is probably the first thing to really notice from this is it's going to start with a lot of verbiage. All right, I have to fill in a 9x9 grid. So it's quite a talkative model, and it's going to burn tokens really quickly. Also, I want you to notice the speed of the model and how much tokens it's generating. It is absolutely just tanking through tokens at the moment. So this is a very small model that's generating a lot of tokens, and I'll show you the difference when we take deep thinking mode off there. But as you can see, it is just kind of waffling and going through. So the first question I really have here, is this truly reasoning, or is this like verbal diarrhea or something, you know? Because I think if you ask this question to like Albert Einstein, a math question, and then Albert Einstein was just like, yeah, let me think this, let me do this, and blah, 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 you would think that you're in crazy town. Alrighty, so it's eventually came back with an answer. I mean, I just want to, just before we look at the answer it's generated, you can see it's thought for 182 seconds. But it's eventually came back with a grid. But I'm just going to ask ChatGPT this for a second. We'll just use the normal 4.0 model, but let's see if 4.0 thinks this is a valid grid. Okay, so the bad news is, and then we're using code to sort of check that there. According to ChatGPT there, this is not a valid grid there. And you see it says row 8 and row 9 have duplicate kind of answers there. And if I look there, yeah, there we go. So row 9, you see the number 8 and the number 8. And then in row 9, you see 9 and 9 there. So it's kind of failed its test there, even doing this for 182 seconds. Let's see if we take the same question for a second. And this time I'm gonna maybe ask the O1 preview model, and let's see how it does. Okay, so O1 previews came back. It's taken a lot less time. It's taken 33 seconds. Again, if you look at the thought process, O1 preview is just a lot more organized. You see filling and creating, filling in Sudoku numbers, etc. It's just done a better job there. But let's see if it was actually accurate. So we're gonna ask GPT-4o to validate this grid, and let's see what it comes back with. And there we go. So O1 preview was able to generate a valid grid, but DeepSeek R1 model wasn't. So okay, so it's not a great start, but you know, maybe it'll do a little bit better. We'll ask a few more Sudoku questions and then we'll sort of move on there for a second. But let's see how it does with validating a grid. Now, this particular grid is a grid. It's pretty simple, but it is an invalid grid. And you can kind of see that already. If we look at this little square here, the 2 and the 2, there's two 2s on the same 9 box. So let's see how it does. Let's see if it can actually validate this grid. Again, we're in the same sort of verbiage here. It's trying to say I'm not super experienced with sudoku, but it understands it. It's working through the logic, and actually it's kind of doing what I would expect it to do. It's going row by row by row, and then it's going to go column by column. Oh, yep, it's picked up those 2 2s in one of these columns here. So I'm feeling pretty good about this. It should be able to recognize the fact that it's an invalid grid. So again, you see the sort of verbiage that's coming out here. It's just going through everything one by one, generating a lot of tokens. And in this case, it's taken about 37 seconds, and yeah, it's recognized there's no duplicates in rows, but it's picked up in column 4. There's 2 2s in there, which it's got. Now it's checking the boxes. And then we should end up in the same space. So 2 7s, 2 3s. So it thinks it's an invalid grid, and it's done a pretty good job on that. I don't need to check this with ChatGPT, because I know ChatGPT, even if it's a switch off code mode, is gonna work. So I'm gonna try another one. I'm gonna pick one more Sudoku grid. This is a way more complicated grid here. So let's see how it does. Okay, so it's done a really good job in this case. So if we actually come back to here, you see there's going to be a couple of duplicates in this box. There's a 9 and there's a 9 there, and then in this bottom square there's a couple of 4s as well, and you can see it's kind of picked up the 2 4s. It's not picked up the 9s there, but it's done a fairly decent enough job of recognizing that and picked up the fact that it's an invalid grid. If I were to go into GPT-4o, I'm going to run this, and then this time I'm going to say no code. So you can see GPT-4o says it's a valid Sudoku grid, which we know it's not. And that's probably one of the big differences of inference time compute or test time compute versus regular next token prediction without chain of thought. You can see it comes to the wrong conclusion. Now, of course, if I were to run this with O1 preview, then we know it's going to do a good job of doing that validation. So whilst that comes back, the nice thing is that DeepSeek is a good model. It can validate grids, for example. It is doing a pretty good job of that. It's actually really good at math. We'll cover that a little bit later on. But of course, it struggles with the generation of grid, whereas O1 Preview is definitely doing a better job. And there you go. O1 Preview has recognized the fact that the number 4 appears twice, and therefore it's not a valid grid. So we're going to have a little bit more fun. This time we're going to play a little bit of tic-tac-toe. I'm giving it a game board. I'm getting instructions and asking what is O's next best move in this case. So if we look at the board there for a second, you can kind of see there's an O dot and a dot, and then there's a dot dot and an X, and then there's an X here. Now the tricky thing for O in this case is O really needs to take control of the center. So really we want position 5 to be coming back from the model. So let's see how it does. And it says O's next best move is position 5 to center. So it secures a strategic position. Again, I'm not going to check that against ChatGPT because it does a great job and it's going to come back with that. And even something like GPT-4 is going to pick that up there. So let's do one more and let's see how it does. This case, what we're going to be looking for is what is X's best next move. So really, what X should really be doing is either trying to get an X in here so that it can do a X all the way down as a line, or X across, so it does that kind of forky thing, or it should really be going for position 3 where it can sort of get it on the diagonal or get it on the top hand. So that will give it a winning move. Let's see how it does. Okay, so it's came back with an answer and it's saying X should choose position 3, which is not a bad position, right? Because that's going to be the winning position, but it hasn't recognized that it can actually have a double win there, and it's talking about how it's going to block O's potential win. It's not recognized the forky move thing. Whereas if I go into O1 Preview for a second, as you can imagine, O1 Preview is going to come back and say, you know, you can guaranteed win the game because you're going to do the forky thing, and then you're going to be able to win regardless of what O does. So let's see what it comes back with. So as you can see, it's came back, it's thought for 38 seconds, and it's saying X next move is position 3. So it's had a look at that. And then by moving to position 3, X creates a fork, forcing O into impossible defense. No matter where O moves next, X can win on the next following in. So you can kind of see it's recognized the forky move thing, and therefore it's going to win. So again, I'm going to call O1 previews doing a better job in this particular case. And again, I'm going to keep going here. So the next one that we are going to try out here is we are going to try a game of Snake. So in case if you've seen one of my videos before, one of the cool things that I created was a little snake game here, so you can kind of see I can actually pit LLMs against each other, or I can pit kind of classic AIs against there. So you can kind of see the snake is going to go around and collect the food, etc. And this is all sort of AI powered. This one is a classic game, but again, I pitted LLMs against this. So what we are going to do is we're going to take the game board of the snake game, and then we're going to find out what the LLM thinks the best move is going to be. So in this particular case, we are going to grab a board. We'll create a new chat here, and then we're just going to say, what's your next move? And then we're going to see what it's going to come back with. Now, while it's doing that, why don't we actually just see what GPT-4o says? So I'm not even going to ask O1 preview at this stage. Let's do a straight GPT-4o. So it's sort of observing the snake's head is at position 1-4, the food is at 0-3, blah, blah, blah. And then its next move, it reckons it should take is up. And again, it's hard to sort of see from the game board in this case, but the reality is up is where it needs to be. But let's see what we come back with. And the good news is it's also saying up as well. So that we're in a pretty good stage. I think it's doing a good move. Again, if I run a different model for a second, so let's say I run a Llama 3.1 for a second, let's see what it does. And again, it would like to move the snake's head up. So everybody's in sort of agreement in this case. So let's try a more complicated example. So in this case, I'm going to give it a more complicated board. The main thing that's going to happen there, and it's kind of hard to see this from this version of the board, but really what is going to happen is if the head is sitting under these O's, and those O's are sitting under the kind of food. I could separate this out a little bit just to show how this is going to work, but it's going to look something a little bit like this. So what's going to happen is that if the head tries to go for the food, it's going to essentially run into its own body, and then it's going to die. So let's just place that in for a second. Alrighty, so it came back and it said its best move is going to be down. Now, the downside of that move, and it's a good attempt, is that within Snake, you can't go back on yourself. So maybe, and you'll see that when I ask O1 preview to come back with the answer, but I'll say the snake can't go back on itself. Okay, it's still saying move down. I'm going to say it can't go down. Pick another direction. Okay, so it's eventually got the right answer, which is move right to position 2-4, but it's taking me a little bit of prompting for it to get there. Whereas, again, if I look at O1 preview, it's thought for 38 seconds there. So if you look here, it says I'm analyzing the snake's moves, up, down, left, and right. Moving up and down and left would cause the snake to bite itself. Moving right is the only safe option. So I think we can agree there that O1 preview is kind of won again. And again, we can ask different questions as well. So I'm going to do another type of question this time. I'm going to say the answer is hidden in the question. This is not a cheese you should eat before bed. Am I right? Now, this is the sort of thing a human would get. We would know to look through the question. This is not a cheese you would eat before bed. Am I right? This is all a little bit weird. And you can see EDAM is there. Maybe I'm going to make it a little bit easier. I'm going to say before bed. Am I right? Let's see what happens. So if we look at that, it's got the answer right. I'm not utterly convinced by the logic that O1 has came back with. You know, it said taking a look at the phrase, sampling the letters, and it's kind of picked up the EDAM, but I'm not so sure it picked up. I'm sort of half thinking it kind of guessed it. But let's see how DeepSeek actually does. Alrighty, so it's kind of went through this. It's sort of struggled. It's went through different ideas: cheddar, Gouda, brie, and then it's sort of tried to imagine the word spree within there, whereas I think it could have got to Edam if it tried a little bit harder. But yeah, no, it's not picked up the kind of the Edam thing, whereas O1 preview has managed it. We could try that again. Let's try with maybe O1 mini. Let's see if it does a better job. Okay, O1 mini hasn't picked up on that at all, which is really interesting. Again, let's see if let's go back to O1 preview. Let's try it one more time with O1 preview and then see if it does it again. So O1 mini said milk, O1 preview got it the first time with Edam. Let's see if it's being consistent and it's actually going to pick up Edam one more time. There we go. So it has got it. The answer is Edam, which is made spelled backwards, which is not useful information, but O1 preview was able to get that sort of answer. So again, I'm calling O1 preview the kind of better model. So I think if I look at logic and reasoning, I think consistently O1 is doing a better job. But to be fair to DeepSeek, it's done not a bad job, but it's more like, as I said, verbal diarrhea. It's just like trying to say as much things as possible as monkeys and typewriters and trying to sort of hit onto monkeys and typewriters and just trying to head on to a potential answer. But I think it is a really small model there because, as I said, it's running really, really fast. And I think I can prove that. So what we're going to do is we're going to move on to some of the math problems and see how it does there. So I'm going to ask it to solve this equation here. And again, it's fairly going for it. So it's got an equation it needs to solve for it, and it's kind of working through the steps. So again, lots of verbal diarrhea. It's really just sort of running through things, but you kind of see step-by-step reasoning on this, and eventually it's going to simplify it, and it comes back to the question, and the solved version is x equals 17 over 12, and that's a pretty good job. The bad news is if I take off the deep think mode there for a second, and you can see that this is going to solve it, but notice how much slower the DeepSeek model here is. This is not blasting through tokens, but it's going to come to the right answer. So this is clearly a bigger model. It's not running at that pace. We know it's a bigger model because it's just not as fast as the other model, but it's going to come back with the right answer. And I think maybe this is something to kind of be aware of, is the math capabilities of the DeepSeek R1 model is great, but actually the original DeepSeek model does a good job as well. Bigger model, not generating as much tokens, but obviously how they've been training has been done in a similar fashion as well. So, I think if I tried to run this against a smaller model, it's probably going to fail in this case. GPT, as you can imagine, is going to solve this fine, as is O1 preview. To be honest, if I run this through GPT-4o, it's going to do a good job. And the reason it's not going to matter on the thinking time here is that because these are math questions, then it just needs to follow the steps and spit out the tokens. It doesn't really need to work out its reasoning too much or try and flip around different logic as you would with the puzzles. It just needs to follow the right steps to be able to train this. And this is why the reinforcement learning training that would have had to be able to learn the steps becomes really important. So I think in these cases, this is why the math of DeepSeek is really good, but and it's really good for a smaller model. But to be honest, the bigger model is equally doing this as well. Again, if I ask another question, so if you say you're giving the equation 1 over x plus 1 over y equals 1 over 7, find all the integer solutions for that. Let's see what happens. Again, this is an example. This is not the R1 model. This is the original DeepSeek model. And you're going to see it's going to come back with the right answer. It's picked up the right integer solutions. It's done a good job. It's fairly slow at that, and it's a bigger model, but it's come back with the right answer. Okay, so now that we've done that, we can ask the same question, this time of the deep think model, and you're going to see this is going to run a lot faster, and it's going to come back with the same answer. But you see this kind of verbiage where it's really sort of just blasting through answers. Again, I think this is a much smaller model because it's really just blurting out the tokens. It's running at a much faster pace than the larger DeepSeek model, but you're going to see that it's going to come back with the right answer in a second. So I think this is a pretty good job, and this is a pretty good math model there, and there you go, it's got the right answer. Again, I don't want to necessarily spend a lot of time with O1 Preview on this, and as you see, O1 Preview has got the right answer, so pretty good in this sense. And then probably the last one that I'm going to try here is I'm going to do a thing which is traditionally called the 100 doors problem, but I've renamed it to the 650 gates problem just to try and fool it a little bit. The idea is you've got a garden with 650 gates, all closed. You make 650 passes through the garden, and then on every pass, you're gonna toggle open, close the gate, etc. You're gonna continue through this process till the 650 path, and then I'm going to ask it what gates remain open. And I only want the first and last 10 gates. And you see it's going to do all of this. It's just working through this, generating tokens. You see, in order to be able to solve this, you're going to realize that it only happens if the gate number is a perfect square. And then eventually it's going to come back with the first 10 gates and the last 10 gates, and then we're all good. So first 10 gates, last 10 gates open. Good job. Funny thing is, if I ask this of GPT-4o, it's a little bit odd this. It's going to do everything correctly, but it's going to struggle to get the last 10 gates. It's going to sort of miss that calculation. So we'll see here, it gets the first 10 gates, but then it's going to cut off and say the last 10, and then it's just going to give me 4. It's not done that, as opposed to sort of going back and doing the calculation. If, of course, I go to O1 preview for a second, ask the same question, it's going to come back with the right answer. Honestly, the DeepSeek R1 models is fabulous at math. It really is good. I would even say the larger DeepSeek models are fabulous as well. But the R1 model is really good at math. It's super quick. It does a great job. And to be honest, I'm struggling to find an example where O1 preview does a better job than R1. These things are pretty much on par for the math model. So I think really, really great job there. But I would say reasoning wise, O1 preview is doing a better job. And there you go. You can see it came back with the first 10 gates and the last 10 gates. Okay, so we're going to move on to a couple of coding things. So what we're going to do is create an app in React that gets the latest time from an internet time service and then updates the time every second with the real time from the internet and keeps it in sync as much as possible. So it's not just using the local clock. I want it to go off to the internet and then create the time. I don't want it to use external dependencies, i.e. I don't want it to use the Axios library, and I want it to create an AI-generated donkey using SVG, and the donkey should blink every time a second changes. So let's see how that does. Alrighty, so you can see I've got a React app here. It's not using Axios, it's using world time, so this is looking pretty good so far. It's updating the time every second. It's keeping in sync every minute, so it's a little bit off from what I asked it to do, but that's okay. Here's my blinking donkey every second, and now it's done my AI-generated donkey. This is probably the first open model that's done a decent job of this. So if I go into my code for a second, let's just kill this. What I'm going to quickly do is just paste this into here. I'm going to do a bun run start, and then let's see how this does. We'll say yes. And that is a blinking Pikachu, but it's close enough to a donkey. This is the first open source model that has done a decent job on this. If you saw my video on the Qwen 2.5 models, you will see pretty much everything else has struggled to generate this. The best model was probably Claude, and the second best model was probably ChatGPT. This is as good as ChatGPT's version. Again, I cover that in the other video. So really, really nice job there, actually. Now, again, if you just to sort of show what I mean, if I go to Claude for a second, and then we'll get Claude to generate the exact same thing, you'll see what I mean about Claude doing a better job. So there you go. I mean, this is the Claude version I'm looking at in the workspace. I could copy the code in. It does the sync as well. I mean, I think that's a better donkey. I think Claude does a better job, but that was really good. That was actually really good. And again, GPT does a great job as well. It's covered in the other video, but yeah, I think the coding capabilities of the R1 model is actually pretty good. Now, just before you think this is all wonderful, this is the best model, for example, I'm going to do one more test here. So in this case, what I am going to do with DeepSeek, we'll create a new chat. I'm going to give it an existing piece of code. Here's some code to extract some image embeddings. It's going to use the GeneAI GeneClip model. It's going to pull 2 images here. I want it to encode and then a computer similarities. I'm asking it to enhance to show cosine similarity. That's the really what I want it to do from that task. And then it's going to go off and have a bit of a think and do that. Whilst we are waiting for that to come back, I will ask the same thing, probably just of GPT-4o. I'm not even going to ask kind of preview. You see GPT-4o has done a pretty good job there. Let me just kind of paste that into here for a second. If I go python embeddings.py, you should see that it's going to do the calculation between the 2 images, calculate the image embeddings, and then calculate the cosine similarity. And you see the answer should be 0.72.4. So now if I come into DeepSeek here, let's see what it comes back with. We'll just do a copy of this here. I'm going to paste this over in embeddings. And then let's see what it comes back with. And it's failed. And it's failed in a weird way, right? Because it's starting to mess around with Torch. You know, this isn't kind of, you see it's trying to use Torch and then function cosine similarity, whereas actually it should be recognizing that it could probably just calculate the cosine similarity with Torch MatMul there. So, and there's multiple ways it could use scikit, etc. as well, but it's kind of failed that. And you know, in Python code, that's not the hardest example in the world. So I would expect it to kind of get that. But in general, it does a good job with Python. It does a good job with kind of React, etc. It just happens not to be getting some of these sort of cases. And again, it's probably not the only example here. So if I say something like rewrite this in Python. And in case you're wondering what this is actually kind of original sort of Dartmouth Basic there. So it's now generated that. It's done that in about 24 seconds. Let's just copy this in and see how it does. Again, I've just pasted it into the embeddings file. It's actually done a pretty good job. It's done that conversion. But if I were to take something a bit more complicated, such as kind of AC-doocy, so say rewrite this in Python, and this is kind of like a AC-doocy card game. It's a sort of a really old kind of basic program there. Let's see what it does. Cool, let's copy that. Let's put it in here. We'll save it. We'll clear this. We'll run Python embeddings one more time. We'll say 10. Yeah, it's doing not a bad job actually. It's not clean, but it's kind of done it. Let's see what ChatGPT does. Okay, so GPT-4o, I've not even gone to preview. Okay, so this is much closer to the original. It's maintained all of the formatting, etc. You lose 20, you know. So although R1 did a really good job of being able to work out the logic of the game and actually get it working, it didn't get all the formatting, whereas GPT-4o is kind of really nailed that. Yeah. Now, if I was being really mean, I could say rewrite this in Rust. Okay, so it's generated the code. We'll do a cargo run. So, you know, this is pretty good, actually. Oh, I blew my wad. Oh, no. So anyway, I was expecting that to do really bad there, but it's actually done a pretty good job there. So there you have it. That is the DeepSeek R1 model. As you can see, it is a really good model. I mean, really good. So when they released the weights for this model, we're able to run this on machine. This is going to be the best reasoning model that is available on open source today that you can run. It is really good. You can see the math capability of that. It is pretty darn close to GPT-4o. It's pretty darn close to O1 in that sense. The math reasoning capabilities are great. I really couldn't find much of a difference. The coding capabilities, I still think GPT-4o is slightly better. But you can see that it was doing a good job, right? It was doing basic to Rust conversions, basic to Python conversions. It did a really good job of my little donkey code. It didn't do such a great job of the embeddings code, but again, it wasn't that bad. Whereas GPT-4o and Claude really kind of nailed this. So I think the DeepSeek R1 model from a coding perspective is great. I still think both Claude and GPT-4o and O1 models are better. Where it probably falls apart is the puzzles, the logic reasoning. I think that the difference between the O1 preview and the R1 models is substantial there. Love the R1 model. Looking forward to the way it's becoming available and being able to run that and play with that locally. Great to have a open source inference test time compute model. Is it better than O1? Definitely not. And please, all the people that keep saying this is better than a O1, it's really not. But it's a really great model. So anyway, I hope this video has been useful, and I'll catch you on the next one.